The gap between real-time processing, which is really on a gigabit per second scale, and ability to transmit, which is really on terabit per second scale, is widening as we speak, therefore posing problems in routing, switching, analyzing much more importantly. And this project is really aiming to close this gap, the huge gap that is growing by the day. This is a DARPA initiative in which real-time processing will be brought to 1 terabit per second, which is orders of magnitude faster than what we can do today. Speaking as a physicist, this is really a project that is going to bring the optical mixing technology to a forefront like never before. Presently, we have to take 320 gigabit per second signal, and we have to make 8 copies of this signal simultaneously. And then we have to go and sample all of these copies at once, generating 8 40 gigabit per second streams. So this is essentially downrating from 320 to 40 gigabit per second signals. We also have to produce optical delay line that is on the order of half a microsecond, continuously tunable while operating at these high rates. So far, the laboratory has nearly met all of these goals. So we have 320 gigabit per second signal copied to 8 copies with very little impairments. We were able to delay the signal as planned, and we were able to sample all of these copies. Presently, we're working on integration to show that all of this works as a real-time preprocessor. This is de facto the first demonstration of 16 signals at 320 gigabit per second, each being sampled by one sampling gate that hasn't been done before to the best of our knowledge. Data processing, data aggregation, optical networking, data centers in general, and security aspects are going to be advanced tremendously. The next phase of this project will be 640 gigabit per second scale processing, which basically means both copying, sampling, and delaying, which is not only twice as difficult than what we are doing right now, but much more than that. And then the project will finally finish with terabit per second real-time processing, which will be orders of magnitude more than we can do at the time. We believe that the bridge between processing and transmission will be well closed at that point. Going beyond that might not be opportunistic, both from the aspects of available physics and available applications, because it's not likely that end user within next decade will be contemplating good fractions of terabit per second.